YouTube channel. Today I'm going to show you how to do statistical analysis for Premier League. Goal of this YouTube video is to find association between the final ranking and number of shots on target, fouls, corner kicks, yellow cards, and red cards. So what I mean by association between the final ranking and those 6 variables is that, for example, maybe we can find better teams have more shots on target, or maybe corner kicks. In contrast, worse team may have more yellow cards, red cards, and fouls, for example. Procedure. So I'm gonna go through 7 steps. First, I'm gonna import the data, and from the data, find the ranking and the variables. Then I'm going to calculate the mean, standard deviation, and total or sum of variables. Create a bar plot by using mean and standard deviation. Then compute correlation between the final ranking and the variables. Finally, create Excel file. I'm going to go through these procedures by using MATLAB, but the reason why I'm going to create the Excel file is that maybe some people don't have access to MATLAB, so I'm going to show you how to do the statistical analysis by using Spreadsheet as well. So let's go to MATLAB. Okay, MATLAB. So I'm going to show you how to import the data, but before importing data, I have to get the data first. So this is a website called Football Data, and it provides all data about Premier League, Bundesliga, Serie A, Liga Española, for example. But in this video, I'm just going to use Premier League here in season 1920 and 2020. You just click it, download it, and you just import it. Then you see here the data, Premier 1920.csv. So I'm just gonna save the data into variable called Premier. So let's take a look at the data. So this is raw data, dimension is 380 times 106. So all rows here represent all games. So there are 380 games in this season, and 106 is a number of variables. So each column represents each variable. So in this video, I'm just gonna use home team, away team, FTL, which is full-time result, HS, home shot, AS, away shot, home shots on target, away shots on target, home fouls, away fouls, home corner kicks, away corner kicks, home yellow cards, away yellow cards, home red cards, and away red cards. Then second step is to find the final ranking. Unfortunately, this data do not have accumulating points or final ranking table, so I have to calculate it. So first of all, this line finds all teams in this league. So there are 20 teams, and this point makes sure all teams start from point 0, and this for loop calculate accumulated points. So basically what this does is, so first for loop goes from game 1 to game 380. So there are 380 loops in first loop, and within the first loop there is second for loop, and it goes from team 1 to team 20. So this is the team's variable, so from Arsenal to Wolves. Then so this if statement with circump function compares two variables, in this case Premier home team and teams here. So let's say the first loop is 1, it means I equals to 1. So let's see the value in the first index is Liverpool. Then the second loop goes from Arsenal to Wolves to find Liverpool. So Arsenal, it's on Liverpool, Aston Villa, no Liverpool, no Liverpool, no Liverpool, no Liverpool, and then find the Liverpool in 10th index. If it's found, then this if statement is satisfied, but there is another statement and another function starcomp, and in this time it compares Premier, FTL, full-time result, and capital H. If it's 1, which means here its H, it matches with capital H. So second statement is satisfied. Then the point is summed up and increases by 3 each time these two if statements are satisfied. Then do the same thing for the away team with FTR 8, and do the same thing for the home team, FTR equal D, and away team, FTR equal D. Of course, if the team ties, points only accumulated or increased by 1. And there is no losing if statement because losing teams do not get any points. Then all points are accumulated and save it as a table with teams variable, and the rank is the variable, saves all table here, and rank is sorted by points in descending order, which means the team who gets highest point goes to the first index, and the second highest point goes to second index, and the third index, fourth index, and so on. Then this rank season accumulates all rank table here. I'm just gonna run this and I'm gonna show you what I mean. So rank season. So let's take a look at the first table. So the first game was Liverpool against Norwich, I guess, and Liverpool won. So Liverpool got 3 points, and obviously Liverpool is the highest so far because they got 3 points, and the rest of the team is still 0. So if you go to the last table, you will see the final ranking table. So obviously Liverpool won the season here, then Manchester City the second place, Chelsea, United, Leicester, and Tottenham. And I only need teams column, so I'm just gonna extract the data with this code here, and the second step is over. Then we can go to the next step, which is finding variables for each team in each game. So the first line here, find all index if this variable matches with whatever in this variable. So rank team is a variable of final ranking. So Liverpool won the season, so Liverpool is in the first index. Then this find function finds, let's say, Liverpool in this variable here, home. Then yes, you find the Liverpool here and save 1 as the index, and the code finds next Liverpool, okay, which is here, and saves 27 as the index, and do the same thing for another team, and of course do the same thing for the away team, which is here. Then by using the index, I'm gonna find the values in different variables. For example, home shots, away shots, home shots on target, away shots on target, and I do the same thing for the rest of the variables. So if I run this, I get 20 times 19 dimension, because 20 teams and 19 games in away and 19 games in home. So I have to combine two variables to get dimension 20 times 38. So 20 teams in the season and 38 games in each team. Then finding variable step is over. We can go to calculating mean, standard deviation, and total. So it's easy. So you just put mean functions std sum to find mean, standard deviation, and total. One thing you have to remember is to define the dimension, because this is 20 times 38 and I want to have a mean of all games, not all teams. So if you put 1 here, this function calculates average points across all teams in game 1, for example. I'm just gonna run this. You can find 20 times 1 dimension. Yeah, it's here. So each team has 1 value, like for example mean or standard deviation or total. Then after I calculated the mean, standard deviation, and sum or total, I can create a bar plot, and I'm just going to use mean and standard deviation. So the first bar chart is number of shots, and looks like better teams have more shots, and the same thing, better teams have shots on target. And I don't think there is a correlation between fouls and final ranking. And for corner kicks, maybe yes, better teams have more corner kicks. Yellow cards, I'm not sure. Red cards, I don't think so. There's no correlation, I guess. So this is an overview of the values from the variables. So this is how you make bar charts. So use just bar function, and you just add error bar x6 1 to 20 in the x-tick labels with rank team, then this x-tick angle creates an angle in y-x-axis and 70°. Otherwise, you get some overlap between the team names. Then the bar plot is over. We can go to the next step, which is find the correlation coefficients. So I'm just going to create one variable. It's just number from 1 to 20 because there are only 20 teams. And I just combine all variables into one variable called stats here. And I'm going to calculate correlation coefficient by using for loop. And this for loop goes from 1 to 6. And to calculate correlation coefficient, I'm going to use a function called coef. It's easy. You just need to put one variable and another variable here. And the stats, like I said, it's a combination of 6 variables. So it starts from shots on target, corner kicks, and so on. And output is correlation coefficient here, p-values, 95% confidence interval in lower bounds and upper bound. So I'm going to run this. First, I want to see p-value. So this p-value gives you if there is a correlation between final ranking and variables basically. So p-value is 0.05 for a correlation between final ranking and shots. So I think there is a correlation between them, and I can say same thing for shots on target, corner kicks, but no for fouls here and yellow cards, red cards. Then I'm going to check correlation coefficients. Okay, so there is a negative strong correlation between shots and the final ranking. So what do I mean by negative correlation? So in this case, more shots, better team, because ranking 1 is highest and 20 is the worst. So better teams tend to have more shots. Then I can say same thing for shots on target and corner kicks, but I think there are some small to medium positive correlation between final ranking and fouls, yellow and red cards, but p-value was more than 0.05, so I don't think this is valid. So let's take a look at confidence interval. So upper bound is negative 0.35, negative 0.49, negative 0.44. So negative medium relationship, and this is for positive. And for the lower bound, it's strong, negative. So which means that for the negative correlation, I usually take a look at upper bound and see this is practically relevant. So true value or true correlation coefficient is at least negative 0.35 or negative 0.49 or negative 0.44, which is at least medium correlation. So I think this is practically relevant. But for fouls, yellow cards, red cards, this is positive value, although this is negative value, which means it contains value of 0, which is no correlation. So that's why p-value says this is more than 0.05. So in conclusion, I can say in Premier League in this season, better teams tend to have more shots on target, and more corner kicks. Correlation coefficients is done. Then the final step is create Excel file. So reason why I create Excel file is to do some statistical analysis in Spreadsheet or maybe in Excel. I'm going to show you how to do that in Spreadsheet, but I need the data to export. So I'm just going to create a table and put the variable I just created right here, like combined variables, shots in home and shots in away, and combine both together and create a variable and a dimension, like I said, it's 20 times 38. Then I make a table and split bars. So the split bar function split column, because if I only put one variable in table, it creates only one column basically. But there are 38 columns in this variable, so I want to have 38 columns. So I put dashboard, I forgot to mention, so it means flip the dimension. So I So this variable shot is 20 times 38, so I put apostrophe here, so it flips. So now it's 38 times 20, so 20 columns. But if I put the one variable here in table, 20 columns becomes 1, and it shows only one column, but I want to split it into 20 columns, and this function helps it. And I'm just gonna define bar1, which is the name of the column, and I'm gonna put new variable names, which is rank team, and do the same thing for the rest of variables. Then if I run this, you will see what I mean. Table here, so dimension is flipped, so 38 times 20. Then if you take a look at the inside of the table, you will see what I mean. So like each column is each team name, and each row is each game. So 38 games and 20 columns. Reason why I flipped the dimension is because in Excel or spreadsheet, it doesn't recognize the variable name in row as far as I know. So I just flipped it and put the name in column instead of rows. Then you will see it when I explain statistical analysis in spreadsheet, and I'm just gonna write a table or make a Excel file by using write a table. And if I run this, I'm gonna create Excel files and save it into MATLAB basically. So I already did it before, and I already have 6 Excel files right here, and I'm gonna download this Excel file and put it on my blog, so you can download it, play around, and do some statistical analysis. So this is it, and I'm gonna show you how to do statistical analysis in spreadsheet. So let's check it out. Okay, spreadsheet. So this is the data exported from MATLAB, and this data is shots on target. And you see each column is each team, and each row is each observation, which is each game. Then what I'm gonna do is calculate all mean, standard deviation, and total. So you just type equal sign, average, and select all column here. Then you put a dollar sign between alphabet and number, and do the same thing for the second or like after semicolon. Then you just click on here and you just dragging, and do the same thing for the standard deviation. The function is stdev, and the total is just sum. Then I just put the ranking here. Then you can calculate the correlation coefficient. So the function is correl, so you just put one variable, which is mean of the shooting on target, and second variable is ranking. And if I do this, you get strong negative correlation coefficient, and this number is exactly the same number as you saw it on MATLAB. Okay, so actually if you wanna see the plot, spreadsheet is not really as flexible as MATLAB, but what you can do is select all row and click on chart. This is a scatter plot, which would work for you, but if you want to have column chart, yes, this is the column chart or bar chart, and exactly same shape as you saw it on MATLAB. How are you gonna put the standard deviation? That's a good question. So you have to do kind of workaround. So either you have to manipulate or like model the data a little bit. So like instead of putting the mean one by one next to each other, you have to do kind of stepwise. So one value here, second value here, and third value here, fourth value here, and you just select all data and same thing, just insert and chart. Then you will see each bar has different color, and you can select standard deviation, but you have to manually put standard deviation one bar. So if you wanna make plot, I would suggest you use programming language like MATLAB, R, or Python. But this is what spreadsheet can do, and maybe it's easier for you, and some people don't have access to MATLAB. They can use spreadsheet, or maybe they can use R and Python. And that's it. Thank you for watching my video, and see you next time.